Hello, everybody. Let's continue where we left off. 1 second, let me get my notes. All right, okay. So we were in section 3.1 looking at logical statements and negations of logical statements, and then those connector pieces and or and implies or the if-then statements or if-then. So what I actually wanted to do is, since there were questions last time about, taking something that's in sentence form and pulling it apart and writing it in symbol form, I wanted to do some more practice with that. So what I'm actually going to do is, so this is section 3.1, continued. I'm actually going to do some exercise problems from the book. And I'm going to screen share. There we go. All right, so just in case you don't remember how to get to your textbook, your ebook, you go to, you get into Hawks, which will drop you into this page right here where you can see your assignments and such. And then up at the top, you click ebooks, which for you probably only have the one ebook, unless you've taken, unless you're taking another class that also uses Hawks, like MS204. There's a stats class that I believe also uses Hawks. But most of you probably only have the one textbook, and you can either click here or click launch. So I'm going to go to the homework for section 3.1 because there's a string of exercises that I'd like to go through. So I'll go over here, chapter 3, hit 3.1, and then flip through. Last time I mentioned a table on page 81 that told you how to negate quantifiers. So there's that, negating quantifiers. Remember, we said to negate a quantifier that says all, you say at least one is not. So if all the pens are blue, the negation of that would be to say at least one of the pens is not blue. Or you could say some are not blue or not all are blue. But the one that really gets to the point is this last one, at least not. I mean at least one is not blue. All right, but let's continue flipping through. If you've used this ebook, it's a little weird to navigate. You can zoom in, and then you have to click and drag, which is pretty annoying. I usually just, if I want to get somewhere else on the page, I just zoom back out and then zoom in somewhere else because I just, anyways, all right. There we go. It's already being annoying. All right, exercises. I want to go to this section here and then also the questions on the next page. Now, I did give you 2 problems from this little chunk of exercises. But I'd like to go through them just for extra practice. All right. So it says using the letters given to represent simple statements. So that's the M and the N in this first one. These are the simple statements, and they're giving the letters. So we're supposed to use M and N to represent these statements. And the proper logical connectives. So that means that symbol for and, or the or the if-then symbol. Express each compound statement, so there's the compound statement, in symbolic form. And also we might need the negation symbol here. So what I'm going to do is I'm going to write it down. All right, so we want, this is 31. It is, I'm going to write it down and then we'll go back to my camera. It is not true. So you can be writing it down too, or you can just mark it as number 31 and just write down the solution. All right, it is not true that Miranda likes both. art and history. What in the world? Okay, it's not letting me go back to Teams. Okay, there we go. Okay, so we have, it is not true that Miranda likes both art and history, where Miranda likes art was M. Oh, I should write that down too. Miranda likes art is M. And Miranda likes history is N. All right. Okay. Some key things to note here. There's a negation going on, right? It says it is not true that she likes art and history. And there's a negation. And also the logical connector piece is that and in between the two statements, there's an and. So I know that I'm going to need what symbols? Well, first of all, I'm going to need M and N, obviously. I mean, those are the letter names given to these simple statements. So I'm going to need M and N. I'm going to need a negation symbol because of the negation up here. And I'm going to need a and symbol like that. And I'm also going to need a couple other symbols that you may not realize right away, not symbols specific to, set theory here. I'm going to need parentheses as well. So this is one of the, this is a good one to look at. You may want to make note of this because this is maybe one of the weirdest ways to negate a sentence that is, or a statement that's been combined by a connector piece. The negation is all the way on the outside, right? We don't say Miranda does not like art and Miranda likes history, right? The negation is all the way out here. So as we're writing this statement in symbol form, we'll start with the negation because it comes first. And what is being negated? Well, the entire Miranda likes art and history statement. So this negation doesn't just apply to Miranda liking art, right? It's not saying it is not true that Miranda likes art and Miranda likes history or something like that. It's saying it's not true that, and then this entire thing, Miranda likes art and history. That means that our entire statement down here with our little letters building the simple statements and the little piece connecting them needs to be wrapped in parentheses. So we're going to have, it is not true that Miranda likes art and Miranda likes history. So that would be the solution here. So the point is, when you have something like this where the entire compound statement is being negated, you need to wrap it in parentheses. And by the way, just a little, you've probably figured this out, but a little note here. Just because this statement doesn't say Miranda likes art and Miranda likes history, it's still the statements M and N, right? It's just when you write an English sentence, we tend to try to not be redundant, right? So we can just say, squishing these two simple statements together with an and, a normal person wouldn't say Miranda likes art and Miranda likes history. They would just say Miranda likes art and history, right? So that's just one of those little subtle things going from symbol to word form or backwards, like we did here, sentence form to symbol form. You got to kind of just be okay with that's going to end up happening, where the English sentence here is not going to show explicitly the entire simple statement every time, because in English sentences we try not to be redundant. We try not to repeat things if it's not necessary. All right, so that's that one. That's probably one of the weirdest ones. Let's look at 32. 32. All right. Oof. That's another reason I don't like this textbook. If you try to scroll instead of moving up and down the page, it zooms in. Oh God, I hate this thing. Okay, there we go. 32. That's fine. Miranda. So I think M and N are the same here. Yeah. So just a different statement here. Miranda does not. Wait, let me make sure I'm reading the right one. Yes, does not like art or. Well, I just went on that whole spiel about how they're not going to be redundant in their statements, and then here comes a redundancy. Miranda does not like history. So they said Miranda twice. Whatever. Sometimes they will, sometimes they won't. This is an example of like how we probably wouldn't speak like this in English, right? We would just say Miranda does not like art, or she does not like, we would say she, right? Instead of being redundant and saying her name again, or she does not like history. Now, M and N are same as number 31. Same as number 31. Okay, so how do we write this using symbols? Well, we are going to need the M and the N. Like what symbols are we going to need? We're going to obviously need M, N. We're going to need, there's a not in there. In fact, there's two of them, so we're definitely going to need a negation symbol, probably two negation symbols. And then for the or, we don't need the upside down V looking thing. We need the thing that looks like a normal capital V. So remember for and, the one we just did, that was an and, right? And uses this, or uses this, and if then, sometimes called implies, just depends on how the statement's written, uses the double-sided arrow. All right, so we're going to say Miranda does not like art. Well, Miranda likes art was M, so we're going to say not M, right? The negation of M, Miranda does not like art, and then or, so or, Miranda does not like history. So not N, because N was she does like history, so we've got the negation of N. All right. Oh yeah, you guys can't see what I'm doing. Gosh, that's great. I wish there was a way to do both, but anyway, sorry about that. There it is. The negation of N, M, or the negation of N. All right. Okay, let's do one with, hang on, I'm downloading attendance. All right, let's do one where we have an implies symbol. Okay, here we go. So number 33. Number 33 says, if I don't eat meat, then I don't get sick. Okay, and the statements are, the simple statements are, I don't eat meat. And B is I get sick. All right, so something to note here. Something to note here is that the first part of the statement up here looks like it's being negated, right? I don't eat meat, but that negation is built into the statement. So we will not negate A here. We will not negate A because A perfectly matches what was in the statement. Something else to note, so we're going to need A, okay, we're going to need B. Something else to note is that this is an if-then statement, so we're going to need this little implication symbol, that little implies symbol. And also, are we going to need a negation at all? We don't need it for A, but B is I get sick, but back here this statement says I don't get sick. So we are going to need a negation specifically for the B at the end. And the way this is going to look when it's an if then, you write the first part, A, the first part of the first simple statement, and then you write implies. So this one goes out of order a little bit. This one goes out of order. Like the other ones are real nice. You read them like in order, like, you know, M or B, and literally the statement is in the exact same order. But here you'll read it as if A, then not B, or A implies not B. So that's just two different ways to read that when it's in symbol form. I'll write that down for you. And by the way, why is B negated? Well, because B is I get sick, but in the statement, it's I don't get sick. So there's the solution. And just so you know how to read this, you would say A implies not B, the not just being the negation. Or you could say if A, then not B. Either one is fine. Okay. All right, let's see. I think that we've done enough here. What do you guys think? Does anyone have any questions, want to see any others? Or if you're looking in your textbook, are there any in this little section here that you'd like to work out? All right, I'm going to assume everyone's good then. And I'm going to go to the next chunk of exercises. Just for a little bit more practice going the opposite way. So we're going to be given given statements, and here they are. Which one am I going to do here? I'm going to do number 41. So I'm going to need Q and R. So the statement Q is, I don't know if it's cloudy or bright outside. So that's a long statement. And then R is I've lost my glasses. Okay. And I'm going to do number 41. Now there is another statement that they give at the top of this chunk of exercises, but the problem I'm going to do does not reference it. There's another one called P, but the problem I'm about to do does not reference it, so we don't need to write it down. All right. So we're given a compound statement in symbol form, and we're asked to write it in word form. So this is a compound statement. It's a compound statement because it's two statements connected with a connector piece here, specifically the and we're asked to write it in word form. I see that we're starting off with a negation of the entire statement. So this is like number 31. So I will start off with something like generic, like it is not true that, just like number 31 started with. So whenever you're starting off with a negation, negating the entire thing, not just the first, this is not just the negation of Q, right? This is the negation of this entire statement. And the way that we deal with that in English grammar is we'll start off with something like, it is not true that, or it is not the case that, something like that. And that kind of like lets you know that the entire rest of the sentence is being negated. It's subtle, right? It's very subtle. All right, it's a subtle change that takes you from just negating Q to negating the whole thing. Like in symbol form, it's very clear. That's what the parentheses are for, right? In symbol form, it's pretty clear this entire thing is being negated. In word form, it's not as clear, right? So it's that's why we're practicing. So it is not true that, and now I want to connect this and this with and. So I'm going to say it to myself to make sure it's going to be grammatically correct if I literally write this and then the word and then write that. I don't know if it's cloudy or bright outside and I've lost my glasses. Yeah, sure, no problem with that. So it is not true that. And then here comes Q. I don't know. Now Q's got all sorts of stuff built into it, but I'm not even worried about it. I'm literally just writing Q. That's Q. And then I'm going to connect it with the and I've lost my glasses. That's R. All right. Okay, let's move on now to section 3.2, which is truth tables. That's enough practice just getting familiar with the symbols. Let's talk about their truth tables. And what the heck does that mean? All right, 3.2 is truth tables. So now we're actually going to be moving into looking at the truth values of statements that we've been given. So we've talked a little bit about this, but not really like formally. So that's what we're going to do now. Okay. So here's something to consider. Consider that any given simple statement can have two truth values, right? True or false. Those are its two truth values that it can be given. Okay. Any given simple statement can yield either a true or a false. Okay, so if I let the statement, rather some simple statements A be today is Monday, and D be, I'm pulling from the example they give in the book, it is sunny outside. But I'm gonna go into a bit more detail than they do. All right, so each of these yields a possibility of two different truth values, right? Today is Monday could be true or false, right? Now we're not, I need to make something clear here. When we're doing all this stuff with these truth values, I'm not asking you, is it actually true that today is Monday? Because you would say true, right? That's not the point. We are not, that's not what we're doing here. We are just like observers in the universe, right? We're not actually here trying to decide if the statement is true or false. We're just looking at all the different possibilities, right? So today is Monday could be either true or false. It depends on the day, right? And it is sunny outside depends on the time of day and weather and all sorts. So it could also be true or false. Okay, so each of these has two possibilities, true or false. So I'll say T or F, and then this one has a T or F. So if I connect them into a compound statement, and I'll just say and, just for the sake of an example. How many possible combinations of truth values can I have? So consider the statement A and D. Today is Monday and it is sunny outside. How many different possible combinations of A and D can I build if each of them has 2? Okay. Well, if I make a little chart here, A and D, A and D here, well, not A and D yet, just the separate A, D. I can have the combination of true, true, they're both true, right? Can have that, that's one possible combination here. I could have the first one being true and the second one being false, right? I can have the first one being false and the second one being true, and I can have them both being false. So I have 4 combinations for two simple statements connected with a connection piece. It doesn't really matter what it is. It just, I haven't even really talked about the and yet. Just for 2 generic simple statements that each have 2 possible truth values, true or false, there will be 4 combinations when I combine them. I can have true, 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 false, false, true, or false, false. Okay. Now, what about the truth value that is outputted by these combos for the statement A and D? All right. Before I get into that, let me write down what I said about the combinations. For 2 given simple statements, there will be 4 possible combinations of their truth values. Okay. And does that have anything to do with what A and D were defined as, today being Monday and it being sunny outside? No, it doesn't. It doesn't have anything. They could be, you know, the cat is blue and the cat is red. Like it doesn't matter what the statements are. There's always going to be this many combinations, because any simple statement, as we defined it, any statement is going to have 2 possible truth values. That means if you got 2 of those, then you're going to have 4 possible combinations. And if you had 3, right, if I had another one, A, D, and C, how many combinations? So there'd be 3 of these columns. So like true, 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 false, true, false, false, although there would be 8, all right? Because well, we'll talk about that more. If it comes up when we do bigger truth tables, we'll talk about that. All right. One other thing to note before I tell you officially what's going on here, before we start this discussion, is that this table is called a truth table. Okay, it's called a truth table, and there is officially a definition of truth table at the beginning of section 3.2, but you just need to know what it looks like. You don't need to know how to like explicitly define it. You can look at the definition if you'd like, but the point is we're going to be working with truth tables and figuring out how different combos affect these different connector pieces. So let's get into that. All right, so how does an AND, so the question now that we're about to answer is how does an AND act given these inputs? So an AND symbol needs 2 inputs, right? 2 values of truth. That's why I've listed them this way. And here are all the possible combinations of those 2 values of truth. So when an AND takes in 2 truth values of true, what is its output? Now we can we can start thinking about, would this person be, the way I like to put it is, would the person be lying if they said this, if they said this out loud, given these truth values? So consider that, just for a moment, that this statement is true. This is the little row we're working in, is statement A is true, so today is Monday. And let's say that statement D is true as well, so it is sunny outside. So if I say today is Monday and it is sunny outside, have I told the truth? Have I told the truth? And you would say, well, yeah, why would, of course. How could it be false, right? Now, what if I said that the first statement is still true, so working in the second row, so it's still Monday, but it's not sunny outside. So D is false. If I say it is sunny outside, that's a falsehood. So if I then said it is sunny outside, if I then said it is Monday and it is sunny outside, is that statement true or false? Does anyone have any idea? Yes, go ahead.
False.
Right, it would be false. And can you say why?
Because it says here, like on the chart, like on the table, sorry, it says like it's false. So like it's not sunny outside. So the whole statement is false.
That's right, yeah. This is how an and is going to work. Thank you, yes. If either part is false, then the entire statement is false. An and is very strict. So that means this one, just similarly to how the second row was false, this third row is going to be false. Right? And this last row is definitely false. If both are false, then the entire statement is going to be false. So the ands are very strict. An and statement is very strict. And if you think about that, that would make sense. Like, consider like this kind of example. If I told you that, let me see, I'm trying to think of an example I would tell you from like instructor to student. If I said the upcoming exam a week from today is going to be, now these aren't true. I don't remember. This is just a hypothetical, okay? I don't actually know how many problems are on the test, but what if I said the upcoming exam is 10 questions and it's very easy? And then what if you took the exam and either of those were false? Would you be mad at me, right? If there were 15 questions, but they were still easy, you would still be like, well, he lied, right? Or if there were 10 questions, but they were all hard, then you would still be angry, right? So in order for an and statement to be completely true, both pieces need to be completely true. Yes, Stephen.
Could you work that part of the table like with the or symbol?
Oh yeah, we're gonna do all of them.
Oh, okay, all right, cool.
Yeah, we're gonna do all of them. Yep. I just like to spend time here because this is, well, we're gonna be doing a lot of these. So.
Gotcha. Thank you.
Now, all right, before we get to or, let's write down some critical points we can make here that will help you with the logic later when you're putting all this stuff together. We can say, what can I say about and statements? So some facts about and statements. Let me write it in. That will help you with these tables. Some facts about compound statements. Okay, they are only true. So here's fact one. They are only true if both pieces are true. And when I say pieces, I mean these simple statements. They are now pretty much saying the exact same thing in a different way here. They are false for every combination, except for true, true, right? If you give them an input of true, true, then they are true. In every other case, they're false. All right. Let's go to or now. I'll leave that there for a moment. Let's make a new table. I'll keep using the letters A and D, but again, it doesn't matter what they are. Your table with two truth values like this, your table will always start looking like this. These 4 rows. Okay. And now the next column is the A or D now. All right, or is much less restrictive than and. This one maybe is a little less familiar. Probably most of you are okay with and, you know, but the or maybe gets a little weirder. So if I say that let me get these out. So we have them all here. Okay. So if I say today is Monday or it is sunny outside, okay, there's our simple statements just for reference. And again, this table is going to be true, and when I complete it, it's going to be true for any simple statements, A and D. It's just nice to, when we're setting it up and figuring out how this table works for the word or, it's nice to have something to consider, right? So if it's true that today is Monday and it's sunny outside, and I say today is Monday or it's sunny outside, then yeah, you're going to say I'm telling the truth. If you look outside, you look at your calendar, it's Monday, you look outside, it's sunny, and I say it's Monday or it's sunny outside, then you're going to say I'm telling the truth. Now, this is where it gets a little interesting here. If I say, so now the setting has changed. Right here, it's still Monday, because A is true, still Monday, but let's say it's like raining and gross outside, it's not sunny. So I say, and we're sitting in class together, and it's not sunny outside, but it's still Monday, and I say, today is Monday, or it's sunny outside. Have I told a lie? In other words, would the output here be true or false? Anyone have an idea? If I say, today is Monday, or it's sunny outside. Yes, go ahead. Kim, go ahead.
Then it would be true.
Right, technically, right? And Isaac, what would the next row be?
That would also be true.
Right, kind of for the same reason, right? Yes, so an or statement is is much less restrictive than an and, right? So these you may not be, hopefully it makes sense, but maybe not as comfortable with, or you might see how people could take advantage of something like this and say, like, what if I kind of sneakily said, like that last example I said about the exam? What if I was like, well, the exam has 10 questions or the questions are very easy, right? Then you'd be like, well, that sucks. Like you haven't really like narrowed it down, right? You know, so that ors are much less restrictive statements. Now, by the way, if both pieces are false, then the statement finally does become false. So it's not like they're always true. So if I said today is Monday or it's sunny outside, but I said that on a Wednesday and it's raining outside and dark, then finally I would be telling a lie in that situation. So let's look at I'm going to give you like a similar little list of facts here because it's nice to have these. So you don't have to re-walk through all the logic every time you build a table. Some facts about or compound statements. All right, first thought, I can say they are true in every case except for false, false. And then really, I'm just going to repeat this, but just kind of looking at it from a different point of view. They are false only when both pieces are false. So that's really just saying the same thing twice, but just from a different point of view. They are only false when both pieces are false. All right, now finally, let's get to the really interesting one, which is the implies, the if-then. That's going to be the one that probably will be a little hard to wrap your head around. So far, we're not venturing, too far from what we kind of are already comfortable with the English language, right? All right, okay. So let's push it a bit. Let's make our table, let's consider we're moving to the implications now. And so I'm going to say A implies D, or if A, then D. Get my combos going here. Same for always. And you've got two simple statements, you'll have the same for, at least for the first two columns. We're going to look at things where things get complicated. You can have lots of columns if you've got a really big statement. All right, now, oh, yeah, let me get the paper for reference here. Okay. Alrighty. I'm going to read these as, instead of implies, I'm going to say if then, because we're probably all more comfortable thinking about it as if then. All right. So if today is Monday and it is sunny outside, so I'm looking, the setting is row 1 where both pieces are true. And I say, if it is Monday, then it's sunny outside. And you look outside and you see both parts of that are true, then I'm not telling a lie. So it's true. It's true. Okay, so probably that one's no surprise. Like, I mean, if both pieces are true, you've seen so far all of the different ways to connect simple statements. If both of the statements are true, then the output should be true as well. So probably not too much of a weirdness happening there. Now, what if I said the setting now is that it's Monday, so A is true, but it's not sunny outside, so it's dark and dreary outside, and I say if it's Monday, then it's sunny outside. Then the output here would be false, right? The output would be false because I'm wrong, because it is Monday. The first part is satisfied. It's Monday. It's Monday. But the second part that I said was false, right? Okay, so that means that I'm telling a lie here. If we're sitting in class and it's Monday and it's dark and dreary outside, and I say, if it's Monday, then it's sunny outside, then you would say, well, no, the first part is right. It's Monday, but it's dark and rainy outside, so you're telling a lie. Okay, so far, like, not too wild. Now these are where it gets weird right here. Okay. So if I say, now here's a new setting. Here's a new row, new setting. Let's say it's Wednesday, but it's a nice day outside. So it's Wednesday, so A is false, right? So it's not Monday. So let's just pretend it's Wednesday, and it's very nice and sunny outside. And I say, if it's Monday, then it's sunny outside. Have I told a lie? If it's Monday, then it's sunny outside. Anyone have any idea? If it's Monday. If I say if it's Monday, but it's not Monday, then have I really told a lie when I say, does it really matter if it's sunny outside or not? Yes, Kim, go ahead.
Yes, it's a lie.
But it wouldn't be.
But if you say if it's Monday, but it's Wednesday.
Right.
Then it's not Monday.
Right.
So that means
that's the point. So the point is that this is where it gets a little weird. But if it's if it's not Monday, then what I've said back here doesn't really apply. So it would be true. And I'll give you all some more examples. Both of these would end up being true. So I think the best way to do this is to keep thinking about more examples. And basically what's going to happen is different examples are going to work for different people. So we're going to look at some more examples of this. It's really these last two rows that are the weird rows. And it's because the first part of the statement is false. So probably everyone's cool with the first two rows. Let's consider these last two rows. So let me think of an example. Yes, question?
I'm confused.
Yeah, I know. We're going to keep working on it.
Okay.
I need to think of more examples. I'm trying to think of one that would be good. Wow, I'm drawing a blank. Trying to think of something relevant, like either to class or to current events or something. What if I said, okay, how about this? Here's something that's kind of relevant, at least to my life. If it's Sunday, then I will go grocery shopping. So what are we doing right now? And by the way, we are investigating what the heck is going on with these last two rows in this table. Okay. If it's Sunday, then I will go grocery shopping. So I go grocery shopping on Sunday because that's just the easiest day for me to do it. Okay. So this is sort of a relevant problem. Maybe you do the same thing too. You go shopping on your weekend. So if it's Sunday, then I will go grocery shopping. Now, consider just this third row. Consider the case when, so the first part of the statement is false. So let's say when let's just say Tuesday, it's the first part's false. And the second part, so consider the case when it's Tuesday. Oh, let's leave it at that. Sorry, let's leave it at that. Consider the case when it's Tuesday. In other words, I'm looking at when the first part is false. So I'm considering the case when the first part is false. Really case is, because both of these, the first part is false. Statement is false. Okay, so this is corresponding to the last two rows here. Consider the case when it's Tuesday. Okay, so our setting is it's Tuesday. And I say out loud, if it's Sunday, then I will go grocery shopping. Let me hang on. I know I'm going slow. Like I know you guys are waiting for the example, but I want to be very careful here. I don't want to make any mistakes or confuse you. That's why I'm trying to go slow. Consider the case when it's Tuesday. If I go shopping on Tuesday, have I told a lie if I say the statement out loud? If I say this statement. That's the, let me scoot up a bit. Okay, so the case is it's Tuesday. It's Tuesday. And I say out loud, if it's Sunday, then I'm going to go grocery shopping. Okay. But then I go shopping on Tuesday. Is this statement a lie? Well, it's not, right? It can only be a lie if the day is Sunday and I don't go grocery shopping, right? This statement only applies to Sunday. So if I decide to go shopping on Tuesday, this statement is not false. If I decide to go shopping on Saturday, this statement is still not false. The statement can only be false. The only way this statement can be a lie or false is if it is Sunday, but I do not go grocery shopping. This, I told you it would get weird, right? Yes, Kim.
I got it now.
Good, good. Yeah.
The first part
You can
said if.
you can feel it click right when you get it.
The first part said if. It didn't say it was Sunday. It said if. So that means I'm
Right.
shopping any day and I'm still right because I said if it was Sunday. It don't mean I had to go on Sunday.
Yes, exactly. You got it. It's like a smart aleck little kid like saying, "Well, I only said if it's Sunday, right?" You know, and then you'd be like, "Oh, you got me," you know, like it's like yeah, that's the point is it only says if it's Sunday. So that means this statement has nothing to do with any other day but Sunday. So in answer to this question I wrote in green, if I go shopping on Tuesday, have I told a lie with this statement? No. The statement is still technically false. The statement technically false. Now, this is not one of those things that everyone just has to come to terms with, and mathematicians and scientists say, you just got to work on it. Like, it's acknowledged that this is weird, and in fact, these cases have their own name. They have their own name in these cases when the first part is false, so the entire statement is true with these if-then things. And I'm going to write what that is. Now, so these last two rows, we call these last two cases vacuously true. How do you spell that? I haven't written it in a while. I think it's vacuous. No, let me look it up. I don't think there's a second U. That's embarrassing. I don't know what just happened, but I think I'm back. That was weird. All right. Okay, so we call these last two cases vacuously true. And that just means that it's only true because the first part is false, right? It's only true because the first part is false. And there's even more we can say about this if you consider that. Remember back when you learned about the scientific method in elementary school and you learned about hypotheses, like if-then statements? You may not remember this, but if you built a hypothesis, it had to be falsifiable, meaning that it needed to be able to be proven true. So good scientific statements need to be falsifiable. Because if they're not, if you leave this case out where it's falsifiable, then you end up just getting all true, right? So you would think that something's true when it's not. And there's a whole lot we could talk about. We could have a whole discussion about the scientific method and why having falsifiable statements is so important. Did you guys send me a message or is that something else? Okay. But what we need to do is, because class is about to end, is we need to write down some facts about these, and then next time we will practice them. So the fact is, some facts about the implication statements, implications. And because you will later on, you will read stuff like this and you'll forget, like it clicked today and that's great, but like you're gonna have to probably, it took me a couple times to keep relearning it before I finally like came to terms with it. So it's going to be nice to have some facts just written down that you can go back to that are concrete. Sorry, how did I say? Okay. They are only false when we have what combo? We have the combination true, comma, false. And I'm going to leave it at that. You can write a corresponding fact that says they are always true except for this case, but I'm going to leave it like that since we're almost out of time. I'm going to say these implication statements or if-then statements are only false when we have the combination true, false. Now, if you're really interested in what I was talking about with the scientific method and all that, there's if you know there's a podcast based out of like I'm doing a podcast recommendation. Wow, anyways, called Stuff You Should Know. I think they're based out of Georgia. Stuff You Should Know, abbreviated like that. And they have a podcast where they talk about the scientific method, and they talk about why having a falsifiable hypothesis is so important. So if you're interested, you could go. I'm not going to have time to talk about it just because we have places to go in our class. But if you're interested, you could check that out. They do it justice there. All right, that's it for today. You guys are good to go. Stick around if you have questions.